Hello everyone, my name is Omid Latifi, and today I'm presenting Aalis, the Autonomous Acoustic Lightweight Intelligence System and next-generation Canadian drone defense solution. So meet our team. This was built by myself and my partner, Pratik Das. I handle the product management side, while Pratik leads our AI and machine learning engineering. Quickly on context, drone attacks have surged 4,000% between 2020 and 2024. A $400 drone can destroy a $2 million military asset. And in the Russia-Ukraine war, drones are driving 70 to 80% of casualties. They're precise, they're cheap, remotely operated, and adaptable to virtually any environment. The threat is here, and Canada is not immune. So what about existing countermeasures? RF jammers lose effectiveness the moment a drone switches to onboard autonomy or uses encrypted frequency hopping links. GPS spoofing is countered by modern drones using inertial navigation and visual odometry, plus a risk disrupting friendly systems. Manual interceptors like missiles are extraordinarily expensive and get overwhelmed by swarms. And physical barriers like nets simply can't handle fast, distant, or swarming targets. Canada's vast Arctic territory and remote infrastructure make these gaps even more critical, and we can't rely on continuous radar and RF coverage across that geography. That's why we built Aalis, Autonomous Acoustic Lightweight Intelligence System. It's a fundamentally different approach. Instead of trying to jam or shoot down drones, we listen for them. Our mission is straightforward: defend Canada's sovereignty, secure Canada's skies, and keep Canadians safe, using technology that's actually affordable and deployable at scale. On the tech side, our front end is built in React for real-time dashboards. Our backend runs on Go. We chose it for its speed and because it handles our portable Canon vector search incredibly efficiently. Our ML pipeline is in Python, running a PANS model. That's a pre-trained audio neural network, which generates audio embeddings. Think of it like Shazam, but for drones. The entire ML interference runs locally, on-premise, with no cloud required. Here's where it gets exciting. The PANS model converts each drone's audio into a 2048 dimensional vector, essentially a unique digital fingerprint per drone audio. We then reduce that down to TSNE for visualization. As you can see, every one of our 10 drone models, A through J, forms its own distinct cluster in 3D space. That separation is what makes identification reliable. We validated this using a vector similarity search pipeline, and the entire system runs locally on a Raspberry Pi 4B. No internet, no cloud, true edge computing. We also use beamforming through a MEMS microphone array to spatially filter out background noise and the drone's own motor noise, so it locks onto only the target. Now let's check out how it works from an end user's perspective. First, the audio is ingested, and then it can be detected via a microphone or via file upload. After it is detected, it classifies not only the drone's model, but also other information such as capacity load, speed, and even its location, which gets mapped. Now we can see that all drones are detected under one map layout. This is a global dashboard used by the military units, irrespective of where the drones are and where and when they were detected. As we can see, some have been detected in Toronto for RISE 2026, and some within Ottawa because we won the Ottawa Drone Defense Tech Hackathon back in November. So everything is already there, and the Aalis AI model also has access to everything for instantaneous information output.
Battlefield Drone Contact Report. 16 drones detected across the operational area. Threat Assessment, Shad 136 Iranian origin loitering.
The entire Aalis prototype, drone, sensors, flight computer, everything, costs $300 to $500 total. That's a complete acoustic detection system for the price of a pair of headphones. Our KNN model, built with a Go audio pipeline, hits 90% accuracy identifying drones by sound and clean conditions. But when we threw in wind, birds, and city noise, generally polluting the dataset, it held at 85%. That's only a 5% drop-off, proving the system's resilience. A Patriot interceptor costs $3.8 million per shot, and you might need 3. An Iron Dome to mirror is around $40,000. Canada's single NASAM's donation to Ukraine was valued at $406 million. Aalis does passive detection for around $500 per drone. That's 1/80,000th of a cost of a single interceptor. You'd need a different chart just to see us on the same graph. Here's the actual build: Raspberry Pi flight computer, MEMS microphone via I2C, and our beamforming array that filters out the host drone's own noise to isolate the target. 650 grams, 15 to 18 minutes of flight. We align with SDG9 through Frontier AI on cheap hardware, SDG16 by strengthening national defense early warning systems, and SDG17 through NATO-compatible interoperable design. Aalis won the Ottawa Drone Defense Tech Hackathon back in November 2025. Acoustic AI detection works, and a vote for Aalis in RISE 2026 would enable us to pursue making Canada stronger, safer, and more secure. Thank you for listening.